Okay, to solve this problem, you just have to consider one. You want to find values of x that satisfy the equation. Sure. Well, one value you know is this. If x were equal to 1, that means all of these x's are 1s, and we know that log of any base to 1 is equal to 0. Just a fact. So that's the definition of a log. So we know if x equal 1, then we have equal 0 equals 0. True. So okay, that's 1. But what's another one? So if x is not equal to 1, what else could it be? Well, here is a helpful hint. You're going to need the change of base. So what's the change of base? Log b a. Well, change of base is going to be log, and I'll just change it to base 10 of a. So this is just 10. And this is going to be the log 10b. You can do anything this way. Or so it could actually be just whatever the new base is. So I can call it base c. Right? That's just the change of base. So this is, you need the change of base. And change of base can actually be found in formula booklet. So check that one out. So what you have here is I'm going to divide both sides by the left-hand side. So this is basically what I'm doing. Log 2x. And you could actually just say it, divide by this. Both sides. You could just say divide both sides by this. Right? Instead, rather than actually just doing it like what I'm going to do here. You can make your life a little shorter. But you just have to state that you're dividing it by that. Right? You don't actually have to write this. So this is basically what I'm saying. Like this is adding extra time. Just to show you what it can do. Right? And of course you do this to every single term, right? So if I wrote this out, now I see it right away. Things are going to cancel, but I'm going to have to write, it's very lengthy. But writing it out will give you that extra time that you put in writing it out. You're going to see how things cancel. Right? But I see it. If you don't see the pattern, right? You don't see where things will cancel, then I highly recommend writing it out. But if you don't see it, or if you don't see it, I highly recommend you writing it out. If you do see it, well then ignore what I'm doing and you can jump right to it. Right, so it's just kind of lengthy here. Right, so again, I'm just going to divide everything by that. Log 2x log 3x log 5x. Then you're doing the same thing for both of these. You can see why it's so long to do this. Right? Like you don't have to do it. You just say divide by what I'm writing down here for each one of these, but sometimes you actually have to put in time to see this. So don't get confused. Each of these are separate. It's just a lot of writing. Yes, for those of you that really already see the point where I'm going with this, then you can skip this part, but you do need to say that you just divide by it, right? So this would cancel with this would cancel with this. Yep, this one cancels with this one cancels with this one and this one cancel, this one and this one cancel, and then there you have it. So what you're left with is 1 is equal to 1 over, I think this is, log 5x plus 1 over log 3x plus 1 over log 2x. And it's at this point that you want to rewrite the bottom, the denominator, in terms of change of base. So the change of base is what you want is the following, is going to be, I think what I want is 1 over, let's say I did log x 5, right? All over log, oh sorry, it would be, this would be log x, and this would be x5, right? Plus 1 over log x. So I'm just making it base x. You're going to see why I do that. There's a rule, and it's also, I think it's actually in the formula booklet that they give it to you. So you get log, do the same thing to each one of these, base x, x, all over log 2, x2. Right, so you see where these would flip around. So this has to flip. So this is going to be 1 is equal to log. Now I'm doing extra steps, a lot of extra steps. You don't have to go, because some of you will already notice where I'm going with this. But this is just for clarity. This is x3 all over log xx plus log x2 all over log x. Now, one rule, log a. If the argument and the base are the same, it's 1. So everything you see here in the denominator is 1. So that really is log x5 plus log base x3 plus log x2. Now I can actually, because there's all these are all the sums, so this is actually, you're taking the product. So I can express this as 5 times 3 times 2, right? There it is. So that means then it's 1 equals log x, and this is 15. Well, that's going to be 30. So guess what? Now I take everything, raise it to x to the 1 is equal to x to the log, and this is by definition of what logs are. Base, this base, right? So this base and this base are the same, so the argument comes down. 30. X is equal to 30. So done. We know that if x equals 1 works, or if x is equal to 30, and there you go.